Well, in this section, you can see that we're going to be moving through a bunch of forms of the quadratic equation. So I've put these notes on the side here that I'd like you to write down on a separate sheet of paper that you can keep in with your notes to keep handy. I think that it helps to organize all the information that you have learned and that you are continuing to learn, and so that are able to pick out the patterns that are going on. We've done all of these forms of the linear equations up here at the top. And the reason I've written those three out, and you should be very familiar with those. We worked a lot with these in Algebra 1, and we reviewed all of these at the beginning of Algebra 2. So these should all look pretty familiar to you. I wanted you to see that just like there are three forms of the linear equation that we work with. Now, as we're moving down into quadratics, which is what we're moving into with chapter 4, these are the parabola-shaped functions. There are three forms of those as well that we're going to use. So they have names, just like our linear equation forms had names. This top one is the standard form for a quadratic equation. If you'll notice, the x squared is what gives it away that it's quadratic. Up here on our linear, we have an x to the first power. Okay, that means it's linear. As soon as we have our highest order on the exponent be a squared, then we know we're dealing with a quadratic. So this is the standard form for quadratic. We also have something called the vertex form, which we'll talk about today. It looks very similar to your absolute value equation down here, which is why I wrote this one in. I want you to notice the difference so that you don't get the two confused, because they both have an A, the difference of an X and an H, and then an addition of a K at the end. They both have those variables. The difference, if you'll notice, hopefully, is the quadratic equation, it has parentheses around the X minus H and is taken to the second power, which makes sense because this is a quadratic. The absolute value equation has absolute value symbols around the x minus h, and it is not being raised to the second power. So that's how you can tell the difference between these two. But just like with absolute value equation, you're going to be able to get your vertex for the parabola with h and k being used. Those will be your coordinate points for the vertex. Just like with absolute value, on a quadratic, you'll have a minimum or a maximum. So you'll have, depending on whether it's opening up or down, you'll use the A again to decide whether the parabola is going to open up or down, just like you did for the absolute value equation. And then we have this last form called the intercept form. This we've worked a lot with. You should have done this in your Algebra 1 course, and I think it'll come back to you as we go through it, I hope. But here in this form, you're able to get your x-intercepts very easily by looking at whatever is being subtracted from your x. So in this case, we're holding those spots with a p and a q. Over here, I've just kind of noted that the vertex form is being shown to you in number 1 over here and in number 3. And then the intercept form is being shown to you in number 2 over here. Okay, so we're going to work with all three. We'll work with standard form when we get to the bottom of the worksheet, but I wanted at least to set that up for you so you kind of have an idea of how this all interconnects with what you've already done working with linear equations. Now, if we look up here at 1 through 3 and we try to match these graphs with the corresponding equation, we can see right away that number 1 is the only one with a positive A value, which means it's going to open up. The other two have a negative 1 in front of them. So we know those are going to be opening downward. So the only possibility for number 1 is to match with this equation over here at C, with this graph of C. All right, so that one was pretty straightforward. Then we go to number 2 and number 3 and try to match them with A or B. And so they're both opening down, which is, we know what we want. This right here, this number 2 is really easy to identify because it's in intercept form. And so if you remember from your Algebra 1 course, if you take any binomial, once it's factored like that, and you take those binomials that have an x in them, and you set them equal to 0, and solve for x, you get your intercepts. Okay, you get where that parabola is crossing the x-axis. So we know it's going to be crossing at a point of 3, which is happening right here, and an x of 1, which is happening here. All right, so very quickly we can see that the graph of B matches with number 2. On number 3, it's going to obviously go with A, but we'll just go through the motions on this one. Just like on absolute value, we have to rewrite this as a difference inside of the parentheses, okay? Because that's what our formula says. Our formula says it has to be in the form of a subtraction inside the parentheses. All right, and then the k value needs to be in the form of a sum. So we've got that one okay. So then we know here that our vertex will be -1, 2, and we can just double check that. Over here, over here, number A. -1 and 2 is our vertex. So we know, yes, that we have done that correctly, and A matches with 3. Moving down to number 4, they want us to label the vertex and the axis of symmetry, so we're going to go ahead and graph it. Again, that needs to be as a difference inside of the parentheses. So I'm just going to rewrite that. We already have it as a sum on the outside, so that's good. So this means that our vertex of our parabola is going to be -1, 3, which we find right there. So that's our vertex. Since this is going to be opening upward, we know that because our A is positive, so we know that this is going to be opening up. We know that this right here is going to be a minimum then. So this is going to be the lowest point on the parabola. Our axis of symmetry is at x equals -1. All right, so we're going to be reflecting through this line here. I'm going to pick a point to the right here. I'm going to pick x of 0. Okay, so that's going to make, I'm seeing where my y-intercept is. I can actually see it when I do that, when I plug in x of 3, x of 0 here, and I calculate that out. Okay, so I'm just plugging in 0 here, and then doing the math, I'm going to get a y of 4. So one point on here will be 0 and 4. All right. And then I know this is my mirror. This is my axis of reflection, so I'm going to take that point and mirror it across to the other side. Make sure it's only 1 unit from that axis as well, and then connect it in a curved pattern. All right, we'll do the same thing with number 5. Number 5 is in the vertex form. If you notice now in the parentheses, it is a difference, but outside here we have a difference for k, and we need that to be an addition. We need it to be a sum. So the way to do that is to change this to an addition sign and that one after it to the negative. Okay, so now we can see that our vertex here is to -1. We can see as well from our A is 1, a positive 1, so we know as well that this is going to open up, so this vertex is going to be a minimum. And I'm going to pick actually let me go ahead and put in the axis of symmetry. Our axis of symmetry then would be at x equals 2. If you notice these axes, they just take the x coordinate. You're just saying that when x is 2, that's what's being reflected over it because this is the vertex, okay? And the axis always runs through the vertex. So the x coordinate on the vertex should always match. It should always be the same as what you're identifying as the axis of symmetry. I'm going to pick 0 for my x again, just because it's just easy. So if I stick 0 in for x and I calculate out my y, I'm going to get a y of 3. So that means I'm going to have another point on this graph at 0, 3. And again, I can see that I've got 2 units between that point and the axis of reflection. So I'm going to go the other direction to the right and mirror it over, and I'll get another point. And then I will connect them. And there you have your graph for that one as well. Number 7, Same idea, except now we see we have a negative 2. So this means it's going to open down. We can see that neither of these is written in the correct form. So we're going to have to completely rewrite this. I'm going to make the inside a difference, and the outside, the same, -4 is the same thing as plus a -4. So I'm just rewriting that so that it actually matches the vertex form of the equation. This is the same. These are the same steps that you went through with the absolute value equation. So hopefully you're catching on to that. We're going to identify the vertex as -1, -4. And our graph is numbered by 2s, so just pay attention to that. So I'm going to be right here in the middle. I know this is my axis. All right, so x equals -1 is my axis of symmetry. I'm going to take 0 again, x of 0 again, so I can see what my y-intercept is. If I plug x of 0 in here, I come out with -6. So one of the points on this graph is going to be at x of 0, y of -6. And then, so that's just one unit over, and on our graph, it's like a half of a grid mark over from our axis. So I'm going to do the same thing on the other side, and then we'll connect. And this vertex is called a maximum. Okay, this is the maximum point because it's the highest point. It's the greatest y value for this function is going to be this 4 right here, -4 right here. Okay, so we've got a maximum here. We have 2 minimums on 4 and 5. Now on 10, they're giving you the equation in intercept form. So it's just another form, and we just use the information that gives us the same information, it just in a little bit different way. And so we just have to know how to use it. So again, when you have these binomials that have x's in them, you can set them each equal to 0. And when you do that, you end up with an x-intercept of -2 and another one at +4. So you plug those in. So x of -2, y of +4. Now those are our x-intercepts, but I need to know what my axis is. My axis of symmetry is going to fall in between those two. Okay, so in order to find the axis of symmetry, I'm going to take those two values, which are called P and Q. I'm going to add them together and divide by 2. So I'm finding the average of the two of them. When I do that, I end up with an axis of symmetry of 1. Okay, so I'm just breaking the distance up in half between the two. That's all we're doing there, is we're adding the two of them together, dividing by 2, so that we can come up with what's in between. And so we see that we end up with an axis of symmetry at x equals 1. Okay. Now I'm going to do what I've done before. I'm going to take my x of 1, because I know this is where my vertex is going to be, somewhere on this line where x is 1. So I'm going to take my 1 and I'm going to stick it into the original equation, and I'm going to evaluate for y. So when x is 1, if I do all that, I'm just going to skip the algebra to save some time. But if I do that, I end up with a -6 as y. So my intercept then, my vertex is at x of 1, y of -6. Oh, I think I did that wrong. That is not -6. That should be -9. Actually, this should be a -9. That'll take us all the way down to here. Okay, so now you have 3 points, and you'll connect them as smoothly as you can. All right, we'll do the same thing on number 13. All right, we've got x minus 3 equals 0, which gives us an x-intercept of 3. And then another one at x of -1. So we'll plot both of those, -1 and 3. I'm going to take those two numbers. These are my P and my Q if we're looking at the way, the form of the equation. So I'm going to take, what you really need to know is this these two x-intercepts. Okay, so 3 plus that -1 divided by 2. Right, so we have an axis at x of 1. So we'll draw that in. Now we know our vertex is going to land somewhere on this, and so we're going to plug 1 back up into our original equation at x, and when we evaluate for y then, we will get a y of 4. So our vertex is at 1, 4. And it opens downward. We expected this, so it's always good to go back and check and make sure that you got what you expected. Now in 16 and 17, to actually go from the quadratic, from the vertex form to standard form, we just need to do the algebra on it. Okay, so if you remember from your Algebra 1 course that when you have a binomial squared, it means you are squaring that whole thing. You're rewriting it twice, and then we're going to do the FOIL method, where you multiply the first two terms, the x and the x multiplied together. You multiply the outer terms, so the -2 here and the x in that first one will give you -2x. The inner terms, the -2 and the x again, and then those last terms, so the -2 times the -2. We're multiplying when we do this in every case. All right, so that's the FOIL method to help you remember what needs to be multiplied together. And then we'll combine the like terms, and now you can see we've got it in standard form, like they asked us to. This is standard form for a quadratic. Do the same thing over here on 17. Right, and this time we have a -2 coefficient instead of a 1 like we had in 16. That's okay, it doesn't change anything. We're going to write that binomial out twice. That entire thing is being squared. All right, so now from here, we need to take care of the parentheses first. If you remember PEMDAS, which we haven't talked a whole lot about yet this year, but a lot of that is because you are doing this intuitively now. So you know we've got to take care of parentheses first. We're going to multiply these parentheses together. I'm just going to rewrite the -2. I'm going to do the same thing. I'm going to do the FOIL method. So the first two terms, the outer, so the x and the 1, x times 1 is x. The inner terms, another x times 1, which would just give us x, and then those last terms, a +1 multiplied by a +1 is going to give us another +1. I'm keeping all of that in parentheses because I don't want to make the mistake of combining this 3 and this 1 together before I've multiplied everything in the parentheses by -2, because if you go back to the original, that -2 needs to be multiplied by the binomial squared. All right, so I'm going to take care of that next with my multiplication. So I'm just distributing that -2 to each of those terms inside. So I should end up with 4 more terms. And then I add that 3 on at the end. All right, we're going to combine like terms. And we end up once again with that equation gone from vertex form into standard form. So just as a reminder, FOIL means first, outer, inner, and last. And it's not anything magical, it's just a way of keeping track of it. If you do it out of this order, you're still going to get the correct answer, assuming you do your multiplication correctly. But it's just a way to help you keep track of it. Make sure you don't miss two terms that have to be multiplied together. And remember, when we do FOIL, we're always multiplying the terms together, and then we combine any like terms at the end. So in 29 and 30, you see a word problem based on this idea. They say the flight of a particular golf shot can be modeled by this function right here, where x is the horizontal distance, and you can see that down here on your label on your x-axis, and the height that the golf ball went is the y. So this right here is where the golf ball was hit. It went up in the air in this curved parabolic shape, and it landed down here on the green. Okay, they want to know how many yards away from the impact point does the golf ball land. So right here, you're looking from the point of impact, meaning when the golf ball was hit, to when it landed. It looks like it's about, I would guess, approximately 260 yards. Okay. And then they want to know on 30, what's the maximum height that the in yards of the golf shot? So what was the maximum? This is the vertex that we're looking at up here. What the vertex was the maximum height that it attained on the shot. So you are estimating what your y is at the highest point there, and we can see that that is probably about 19 yards, maybe a little bit more than that, but we're going to say about 19 yards. Okay, so those are actually pretty easy to read if you think about it as like, a graph of an actual ball flying through the air and coming back down to the ground.